Right. So thanks for coming out and joining the talk. I'm going to be talking about composable infrastructure, which is an approach to infrastructure as code, which helps with scaling, and by scaling I mean the amount of infrastructure managed and the amount of people working on and using it, and also to be able to evolve it. So this kind of connects very nicely with Rebecca's previous talk about evolutionary architecture, to talk about how infrastructure and cloud fits into that. So I want to start by talking about why do we use cloud technology, why do we use automation tooling and these kinds of things. And the ultimate reason is obviously to deliver value more effectively, value to our customers, to our users, to our business, to our stakeholders. So this is meant to be something which will help us to do this. And this is manifested through applications to the software that run and provide services. The infrastructure itself is quite messy. The infrastructure provided by a cloud platform or by even by the data center and so on tends to be it's some pieces. It's a lot of pieces that you can use to run applications on, but how you use it is the tricky part. So we assemble infrastructure, those kind of basic levels of infrastructure pieces like storage and compute and networking. We assemble those into capabilities, into infrastructure capabilities that can then be used by applications that we can use to create environments to deploy applications into. And we use infrastructure as code to do that. So what I'm kind of talking about today is mostly focusing on this middle layer here of how do we use infrastructure as code to build this middle layer of services and capabilities for our applications. As I mentioned, this is scaling to multiple teams that creates challenges. Multiple teams who are using infrastructure, multiple applications running on infrastructure, but also multiple teams of people who are working on infrastructure, building different parts of the system, and how do these fit together. And I would say one of the biggest challenges is change. How do we make changes to the system? With infrastructure, when I talk about change, a lot of times people ask me, why do we need to worry about that so much, right? We do application deployments, we have automated tests and pipelines for our applications, but infrastructure, once we build an environment, do we really need to worry about that? And I think drawing on and building on what Rebecca was talking about with evolutionary architecture, it's quite important to think about the fact that your entire system, down to the infrastructure and beneath, needs to be able to evolve, as well as the applications, in order to support applications. So, and also, our infrastructure needs to be built in such a way that makes it easy to deliver changes to applications, to make those changes and see those through. But the infrastructure itself will tend to change. It does tend to change. I think often we don't think about that very much. We like to think about, we'll provision a server, we'll provision a database, we'll set up the networking to connect things, and then it's done and we don't need to touch it anymore after that. But this isn't true. So if we think about some of the kinds of changes we typically make to infrastructure, well, one is simply provisioning new infrastructure, whether it's for a new service, a new application, or even for, say, an environment that's needed to test an application. And that's quite frequently, it's something we need to do very frequently in this world where we're introducing new applications and services, and we're experimenting and doing all of those kinds of things. We need to be able to quickly and reliably provision quality infrastructure to provide quality services. We also need to upgrade the system software. So this is one of the areas where we start to see that when we take that mentality, the infrastructure doesn't need to change, so we don't need to think too much about how do we change our infrastructure. This is where we find it's quite common in many organizations that we're running very old versions of, say, operating systems or databases or messaging systems, and we're constantly worrying about, well, is it going to go out of support? Is the vendor of that software going to stop supporting it? Or are patches and security updates no longer going to be available? And so this is where, if we focus on being very good at upgrading and changing our infrastructure, it makes it easier to keep things up to date, and also which in turn makes it easier to keep things secure because we're running updated and patched software. So patching, applying patches, even aside from upgrading the versions of the major software, what about rolling out those patches? How easily we can do that. So I was working with one client where we built some pipelines, and as I'm going to talk about, we built pipelines for making changes to servers in our environment. And this was around the time, some years back, where one of these one of these bugs came out, and that was announced security flaw in the SSL software. It might have been Heartbleed, I can't remember. It's one of those ones that had a name and made it onto the newspapers that, you know, executives at the company saw this and said, oh, we have to worry about this. We have to do something about this. And so I remember the CIO came to our team and said, look, we need to stop the work that's going on right now, and we need to prioritize making a plan to roll out the security patches. We need to make a plan, figure out how long it's going to be, how much effort it's going to be. And we said, well, actually, sir, we applied that patch this morning because we have a process where we're continuously, when new patches and updates to the software comes out, we have a pipeline that tests those changes and decides, using things like fitness functions that Rebecca was talking about, it decides, is the system still correct? So fitness functions, application tests, all those sorts of things, the automated testing that we had in place meant that we could be sure and confident the patch was good, it wasn't going to disrupt operations, and we could go ahead and apply that into production quite easily because that was our routine. And so it was quite satisfying to be able to say that what was normally a very disruptive and difficult process of patching software was something that was actually quite routine and didn't really need any special attention. There's things like configuration improvements to our infrastructure, optimizations, fixes. When we have an incident, when we have a problem, applying a fix is a change, as is recovering from failures. All of these things are types of change. So it's very important that we think about our infrastructure as something that does need to change very frequently, and that therefore we need to be not only fast at doing it, but making sure that it's reliable. And a good way to understand about your change, your effectiveness at making changes, is to think about the 4 key metrics. If you're familiar with these from the State of the DevOps report, these are deployment frequency and lead time for changes, which together could be thought about as speed, like how fast are we making changes to the system? Then people also, often that raises concerns, well, what about the quality and stability and all of those things, particularly for an organization like Globo? You can't afford to have downtime, you really need to have very stable systems. So the other 2 key metrics are the change fail rate. We need to keep track of how often when we make a change, does it either cause downtime, or even we should measure things like, is there a change something that has to be rolled back? Are we making changes too quickly that they're not actually correct? And then the time to restore service when we do have a failure, that we're able to do that quickly. And those together could be thought about quality of service, operability, those kind of things. And so the State of the DevOps report, if you're not familiar with it, they did surveys, they've done surveys over a number of years now, where they look at organizations and how effective they are on these 4 metrics. These are the metrics they found were most important and most useful in indicating the performance of the organization in other factors. It had the highest correlation to things like even revenues and profitability and share price of an organization. Organizations that are good at these 4 things tend to be good at those. And an interesting thing is that they found that the highest performers, again, those organizations which perform very highly in terms of their business outcomes, tend to excel at both throughput and stability. So of those 4 metrics, whereas I think we often think naturally that we have to trade off. If we want high quality, we need to go slow, or if we want speed, we have to be, give up on quality. We have to move fast and break things. But the research from the State of the DevOps report and the Accelerate book shows that actually these are not trade-offs. That organizations don't tend to be good at one side of these or the other. They tend to be either good at both sides or good at neither, because these are self-reinforcing. Actually, speed and reliability are mutually reinforcing. So the faster you can make a change, and that you can make it reliably without having failures and those kinds of things, and the faster you can make improvements, the faster you can make corrections, and the more often you can do these things, so that you can improve the quality of your system, you can reduce technical debt, you can have a higher level of quality in your system overall, because you are very frequently, every small thing that comes, that small problem that you might see, you can fix that rather than adding it to a list of things that we'll get to when we have time, because it's very difficult to make those small improvements if you don't have these things all working very well. And one of the phrases that I like from the Evolutionary Architectures book is that change is something we can't avoid. Our organizations need to be able to change because we need to get things to market quickly. We need to find new opportunities, exploit new opportunities, look at new technologies, things that users are doing that we need to support. So we can't say let's slow down change and let's ignore the change, but we need to exploit it. We need to use change as an advantage, as something that, again, is helping us to continually improve and evolve our systems. So composable infrastructure is basically taking this idea into our infrastructure. And I've got 3 pillars that I'm going to talk about today, 3 aspects of this: architecture, delivery, and value. The first of these, architecture, is about using infrastructure stacks as a component of infrastructure, as a reusable, composable component. And another term from the Evolutionary Architecture book is the idea of an architectural quantum. An architectural quantum basically is a unit of infrastructure or a unit of your system that you can make a change to kind of independently, and that is kind of a cohesive unit, a thing. So for infrastructure, I talk about an infrastructure stack. What I'm talking about here is, for example, with Terraform, it's a Terraform project that has a state file associated with each instance of your system, or CloudFormation, uses the term stack directly, as does Pulumi. So with all of these kind of tools that basically let you define what elements of infrastructure that we want to assemble and provide into a cohesive and useful thing. So that's the idea of a stack, and the idea here is that we want to make this be the unit that we use of composing our architectures from, that we look at what different stacks we create, that we need to create, how to organize our infrastructure into these stacks and integrate them and deliver changes to those. There's a challenge as an infrastructure project goes, as a stack, let's say a Terraform project grows, are that it becomes slower and slower to apply a change. So for instance, I was working with a client here in London in the UK in healthcare, where they were using Terraform on AWS, and it would take them, when they ran the Terraform apply command on their infrastructure, it would take more than an hour for that command to complete, which, if you're familiar with these kind of tools, they tend to be slow. They tend to take maybe a few minutes in the worst case to apply a change. But an hour or more is quite significant. And this was because they had everything in an instance of their infrastructure all in one project. So they had over 50 database instances inside a single Terraform file that you would apply. So this is a problem, and this makes, obviously, the slower it is to apply a single change in your system of that architectural quantum. So here your architectural quantum is quite large. And that makes it hard to change frequently, hard to deliver changes frequently. And there's an increased risk. Every time you do make a change, because there's so much in it, there's much more potential that something will go wrong. And if something does go wrong, because there's so much more in it, there's a lot more things that you can break and affect. Even if you're just trying to change one little thing, you might change something that you didn't really think of as connected to that, but because it was in the same infrastructure project, it was affected. It's also very hard to fix things in these large projects. For one thing, because there's so much in there, it can be difficult to kind of pull apart and understand where exactly is the problem, and to make the fix. Well, how do I make that fix without breaking other things around it? But it's also hard to fix because it takes so long again to run. So you make your change, you apply it, and then you find out, well, the change didn't quite work, and so you have to do it again and again. So clearly we want to take the lesson from software architecture and say, let's move from a monolithic architecture for our infrastructure projects and break it into smaller pieces, smaller quantums. We'll break it into small, loosely coupled stacks. We want to deliver changes to these stacks independently. So we want to be able to change the code for one infrastructure stack and not have to coordinate. This is exactly what Rebecca was talking about with continuous delivery and these kinds of things. We need to be able to do this to our infrastructure changes so that we don't have to coordinate across so many teams in order to make a change to one thing. Now, often people wonder about code modules for infrastructure, things like Terraform modules or templates in CloudFormation. Most of these languages have the idea of modules, which is a way to organize your code into reusable components that you then import into your stack. And so those are useful to organize and to share and reuse code for infrastructure. But they don't help with that problem with the size, because when you run the apply command on your stack code, it pulls in all the different modules and then applies them, and again, you have a very big project. So with that project, with the healthcare organization, one of the first things that the client had tried to do was to modularize their Terraform project, but they found that actually didn't help them. It was still very large and brittle when it came time to apply it to an environment. So that kind of leads into the delivery aspect of things. How do we deliver infrastructure changes with these composable stacks? And the answer is the same way that we do for software, using pipelines for our infrastructure code and infrastructure components for those stacks. So to think about why are we doing this? A common thing that we have to do is we have multiple environments. I've shown it here as a very simple setup with 4 stages: developer, test, staging, and production. Obviously, in most organizations, it's different, and there may be more to it than this. But the basic idea of I have multiple environments that we're testing our applications in. How do I manage the infrastructure code for those? So a lot of people, a lot of teams start out by taking this approach that I call snowflakes as code. Rebecca mentioned environments where you have, I think she should environment number 12, say, which is a bit different and from the other environments and causes inconsistency and causes problems for the continuous delivery of software. Often we talk about those environments as snowflakes. Environments are, each environment is a special thing that's built specially by hand. This is what people often will do for infrastructure. They have a separate infrastructure code project, Terraform project, CloudFormation, whatever, for each environment. And this invites inconsistencies. 2 ways that they often do this might be with folders. So you might say you have a structure where your code for your development environment is in one folder, testing, staging, prod each have their own folder, and maybe you copy infrastructure code from one to the other. You make a change and improvement to the dev environment, to the infrastructure there, and you test it. And if you're happy with it, then you copy the infrastructure code from dev to the testing, and then from testing, staging, and the prod. The problem with this is that people tend to make the differences between these environments tend to stay in the code. So people say, well, remember when you copy the code from staging to prod, change all the strings that say staging to prod, otherwise something might break. And then if somebody makes a mistake with that, then things break in production. So it's we need to avoid that, as we would with application code. We don't have separate copy of our application code that we compile separately and build separately for each of the environments. We create a single build. We create a single artifact that we deploy into each. And so just another way that people tend to do the snowflakes as code is with branches, where they have a separate branch for each environment. And there's nothing inherently wrong with that, but it's the fact that people will then tend to make those changes in the branch. In the branches, and the branches will be slightly different. The code in the branches will be slightly different. So they might merge changes from, again, they do a merge from staging to production, but then you have to go and make changes to it and tweaks and clean it up because production has some different things in there than staging does, and you don't want to make a mistake with that. So because there's this manual process involved and the differences between environments. So instead, what we would like to do is to promote unmodified stack code across the instances, just as we do with applications. So this is the idea that whatever the mechanism, whether you put it into an artifact or use branches or what have you, that you don't make changes. You take the same code, the infrastructure code, that you apply to development. Once you test it and you're happy with it, you push it into the next environment without any changes. You have no difference to the code as it moves through environments. And if you find in a later environment, if you find in staging, oh, there's something wrong here, we need to make a change to the infrastructure code, you don't change that code in the staging. You change it back in the original, and then you run it through the dev, test, staging, and then ultimately to production, so that you know that you're testing that change to the infrastructure code in all the previous environments as you should. And where you do need to have differences between environments, so maybe the size of what you provision, the size of, say, a cluster, or the size of data storage devices or what have you that you have, obviously it tends to be larger in production than for other environments. You put those as configuration, instance configuration parameters that you pass in for the given environment, and the code uses that, but the code itself doesn't change. And obviously this implies then use pipelines, the same as you do for application code. Whatever kind of tooling you're using to deliver changes to your applications, application artifacts between environments, use the same or similar pipeline service or tooling to do that for your infrastructure code as well. You want to have that process automated and centralized so that the process of going from staging to production doesn't involve anybody doing anything manual, editing anything. It's simply a matter of clicking a button, maybe reviewing something where you have governance, process, and compliance. It means that somebody has to review it. You can review it, but then you click the button and the automation takes over and does the same thing that it did for each of the other environments. And then you'd like to decouple your delivery pipelines for the different stacks. And so this moves away from having all of the infrastructure having to go together at once. But as we do with microservices for applications, we say we're going to use techniques, and there's a lot of complexity and things that you need to think about with these techniques in terms of the design, in terms of decoupling, in terms of integration interfaces between these things. But much of the same kind of principles and practices and patterns that we use in applications to do these kind of things can be applied to our infrastructure as well. So that it's possible to say, I'm going to deploy the changes to the infrastructure for this part of the system without having to coordinate across everything else in the system. And so the third pillar, the third thing I'm going to talk about with this composable infrastructure idea is the idea of, I was thinking about value and this idea of application-driven infrastructure, that we build our infrastructure in order to deliver value via the applications. So as you think about our overall system as having these kind of layers of applications and then infrastructure capabilities underneath them, that might be things like container clusters, databases, messaging, and so on, and the infrastructure underneath being the raw pieces of what you get from either the virtualization platform that you have in your data center or the cloud platform that you're using. So in the old days, what I would say the Iron Age approach to this is we build the platform in isolation. You have your team who said, we're going to build a platform, we're going to build infrastructure, we're going to build environments, and that later on the application will just be deployed into those environments. This tends to create friction for productivity. So for those application teams, when they find that they need to make changes or add things, or maybe introduce a new service, or they have a need for something new in terms of infrastructure, some piece of infrastructure, a system, or whatever they need, it creates friction because they then have to go and talk to the folks who run the platform, and it goes to, again, to that siloed thing that Rebecca was talking about you have now, you have to create a project in order to do this. And oftentimes as well with platforms, it hurts adoption because of that friction. Developers will avoid using the platform because they say it's not useful to us, it gets in our way, it slows us down. And if the thing that the applications are doing, if there's work being done there that's considered high value to the business stakeholders will often tell them, well, okay, just go and use the cloud and ignore the platform that those people are building. So I have seen a fair number of platform projects fail because they were built really in separation from the applications. So the approach we like to take is application-driven infrastructure. And this is the idea that we start by looking at the applications, and whether it's specific applications and with smaller clients than obviously you folks, we might have just a few applications. So we look at each application and what they need. With larger organizations with large portfolios, so we've done this with, for example, organizations involved in the public sector here in the UK, where they're serving like the entire population in the very large and complex systems. And so what we did with them was we worked out the types of applications, kind of patterns. We had some applications which were maybe high volume, needed to scale up and scale down, had different demands for that, whereas other applications maybe had different needs, more stability, maybe more, or other things that they need, or also in the tech stack and the kind of capabilities that they need. So some applications, working with a bank right now in Turkey, where they have some applications that are running on WebSphere, running on top of AIX servers, and so they're having to bring those over to more modern platforms, but they're not able to take them, whereas they have newer applications that are running in containers and running on Kubernetes clusters. Some of their older systems are not ready to make that shift into containerization yet, but they still need, they still need to kind of change those. They wanted to move them to Linux and to newer versions of the Java application servers, so that they can, keep them, more up to date and manage them better. So, it's categorizing the different types of applications and workloads that we need to run, and then looking at what are the different capabilities that we need to provide to those. Container clusters versus virtual machines versus physical servers. In some case, they need physical servers. And so we have to say, well, we need to be able to provision and provide physical servers in the data center, but do it on demand automatically, automatically provision servers. So those were some of the kinds of things that we worked out that we needed to provide to those applications and provide a way that they can consume them on demand. And so this takes the idea, I think an important thing is thinking about where to draw the boundaries when you're infrastructure, where to define different capabilities, where to define those infrastructure stacks to build those capabilities, how to break those apart, where the seams are. And so domain-driven design works in this, so you can kind of take it down. So if you're familiar with domain-driven design, for how you look at your business domain and what your applications are doing, what they're providing to your users, your customers, and your business, you can bring those down into the infrastructure and be thinking about, so for example, one organization I know about has the idea of what they call a traffic. So they basically moved away from having a network team and what they call a traffic team, and traffic and availability. So what this was, it was to do with networking. It was how do requests from users come into the system and get to the applications, but also had to do then with things like load balancing. How do we make sure that we're handling the load? And also had to do with things like failover. So how do we manage failing over the workload and therefore the traffic, when something goes wrong? In this case, they're running on AWS, so they were looking at if there's a failure of AWS in one region, we need to make sure we can automatically or very easily fail over to another region or availability zone. And so this team, all of these things actually, when we sat down and worked it out, these fit well together. And so we decided, okay, let's build a domain around that in terms of our platform domain and our infrastructure domain. And this also, to touch again on Conway's law, there's so many things that Rebecca talked about which fit into this, right? These things all line up. So Rebecca was talking about Conway's law, where your organization structure will end up driving your architecture. And so this is one of those things we decided these things around availability and traffic go together. And so we'll build a team around that. And then we build the infrastructure and the architecture and the systems around that. And so again, as I mentioned, we're going to use the stacks. Those infrastructure stacks are what we're going to use to build the capabilities. So then we need to draw boundaries for those infrastructure, getting down to the level of the infrastructure code. Like, where do we draw the boundaries to make those Terraform projects or CloudFormation project or whatever you're using to make those small enough? So one obvious kind of criteria for deciding this is a change. Where do changes tend to happen? So if you look at typical changes, and I'm not talking about the changes as they were implemented. So we had a firewall rule change, right? Well, why did we have a firewall rule change? Well, that was a part of a larger change. That application, new application was being deployed. Okay, why was a new application or a new service being deployed? Well, we needed to do something different in this application. And so you kind of go up and it's like, what were we trying to do as an organization? What are the typical things we try to do? And where then do the changes tend to need to happen? Because the idea here is you want to minimize how many different parts of the system you have to touch with a typical change. And so this might result in some different boundaries than you might expect. So with infrastructure, people often go to natural boundaries like networking. We're going to have networking as a boundary and stacks for networking versus stacks for databases versus stacks for other things, because, well, that's probably where our team is structured, right? So we're going to reflect the team structure when we do that. But with automated infrastructure and cloud, often those don't line up quite right when you think about it. For example, a lot of networking is specific to an application. So if we're a firewall rule change or a load balancer VIP configuration, will tend to be associated with a single application. And so it can be useful to say, we're going to have some common network infrastructure, so subnets or VLANs or so on, those kind of high level boundaries or constructs, that we're providing, or maybe container clusters or so on. But for an application, there's some specific set of infrastructure which is just for that application. So if we put those into a stack for an application's infrastructure, that means we can change the infrastructure for an application without having to worry about breaking other applications the way we do if we have all of the networking, all of the, say, firewall rules in a single stack. We're making a change for one application can potentially break others. And so this naturally goes then back to the team structures. So you would like to align your stacks so that each stack is only owned by one team. You shouldn't have a stack, an infrastructure stack, where more than one team is making changes to it, because then you have to coordinate those and avoid breaking things and coordinate the releases. Well, I need to make, I've tested my change now and I need to release it. Well, we have a change that we haven't finished testing yet. You have to wait for us. So this is the kind of thing where you want to make sure you can align those up, and whether that means changing, reorganizing your teams a bit, or whether it just means reorganizing how you think about your infrastructure and your applications to match that and make that more smooth. Governance also plays into it. So for instance, some parts of your system might be subject to stricter compliance regulations and those kind of things. So a common one is credit card handling, where you have to have PCI compliance for the parts of your system where credit card numbers, which are handling credit card numbers. And so you can look at your infrastructure and say, which parts of our system are handling those? And we can put those into a stack or a couple of stacks, and we can apply tighter controls over changes to that infrastructure. Another whole topic, but we can use the automation in the pipelines to make that very easy to do, and very easy to kind of make sure that everything is auditable and that the checks that must be in place are enforced, and we can track that. But in any case, like that's a stricter controls we might need over other parts of our system where they're handling things like maybe images to be shown on a marketing website. And so we might say, by separating those out into different stacks, that means we can make changes to the parts of the system which have less rigorous compliance requirements without, much more easily. Whereas when we have everything in a single thing, a change to something trivial, like an image on the marketing website, might be subject to PCI compliance steps that we take just to make sure that we haven't fallen and done something wrong with that. And then similarly with resilience, the idea that there are different parts of our system that we might need to scale differently. And so in many cases, what we find is that we want to replicate some aspect of our infrastructure. So for instance, if we have one infrastructure stack which builds a Kubernetes cluster, we might say we might need to have multiple instances of the cluster, especially as we scale up. And so we can use that single infrastructure stack project to create multiple instances and to tear them down as we don't need them, or to deploy them in different regions and this kind of thing. So these are some of the kind of things that are useful to think about when deciding where to draw the boundaries of your infrastructure. And these have to evolve. All right, so one of the things to caution against in that spirit of evolutionary architecture is we won't get this right at first. So we need to think about, we need to find a good initial structure for this. And typically it will be not too fine-grained. It'll be, it'll be more basic, and then we'll learn over time what's the right ways to break things up. And we need to have the systems and practices in place to be able to make those changes to things very easily and comfortably. So I'll close with a few references to books. So the Infrastructure as Code book is the one that I wrote. These other books are all by people who worked at ThoughtWorks, at least at the time they wrote the books, and these are all related, right? So continuous delivery is something that we want to support with our infrastructure and do with our infrastructure, as well as taking microservices concepts into our infrastructure as well. And obviously I've been talking about evolutionary architectures a lot because it is quite core to this. So thanks very much. I'm not sure, hopefully we have time for some questions. I've been, I was a little bit late, so.
No worries, Kief. We still have time for one question for the sake of our agenda. I have a very nice one that was posted here on the Q&A. And I'm gonna, it was already posted in English, so I'm just gonna read it out loud, okay? Infrastructure tests, end-to-end tests on a staging environment can be very costly and hard to maintain. false negatives and positives can be fairly common as well. Do you have any tips to improve the speed and reliability of an infrastructure as a code pipeline?
Yeah, I think it does come back to making the things that we're working with small. So the infrastructure stacks, that kind of architectural quantum. So the bigger chunk of infrastructure that you have in your pipeline, in each pipeline, the slower the tests are going to be. So by breaking your infrastructure down into smaller things, each with their own pipeline, ideally each pipeline and what it's testing and delivering is small enough that you can kind of speed up those testing. And you can rely on things like contract testing and so on to try to catch, to make sure that in terms of where those different bits of infrastructure need to integrate, that you can test those without necessarily having to put everything together in one massive staging environment and test them all in one go. And there are also things about, there's a lot of kind of infrastructure testing is hard. The tooling is not as mature as it is for application testing. So it's quite important to think very carefully about having just enough testing. It's very easy when you're used to writing, say, unit tests for applications, it's very easy to add more unit tests and they tend to run quite quickly. Whereas for infrastructure, I think you need to be a little bit more rigorous about keeping your test suite pruned to make sure you have those that are necessary tests that and avoid tests that maybe aren't adding as much value.
All right, Kief. Since we still have like 2 minutes left, I'm gonna go with another question. One thing you mentioned during our talk is about maintaining a stack of code that is basically limited to each application, right? How to deal with standards and codependencies and this sort of stuff when this is the case?
So there's a few things you can do here. One of the more basic things is making sure if you have an application team which is making changes to their own infrastructure at this level, they should have the knowledge to do that, and they should be running tests in their pipelines. And so people who are working on those kind of standards and consistency across things, let's say, can do kind of reviews of are we testing the right things? Is everything in place that should be? So we do that a lot. We call technical assurance, where we have groups of the practitioner that tend to be people across teams, visiting each other and reviewing what they're doing and having conversations about that. But you can also build, so in the stacks that I'm talking about, maybe things that you can build in a kind of reusable way, and especially in a large organization. So if you have, for example, a common type of infrastructure for applications. So let's say you have a lot of applications that run on JBoss and use the Oracle database, and tend to work in the same ways. You can create infrastructure stacks which say this is the infrastructure for that kind of application, and it will provision your pool of virtual machines. It will provision your database and the networking to connect it all up in the proper way. And then you can provide that to teams so that they can use it without having to build it themselves, and so that you can kind of reuse that. I think you guys have this kind of thing, don't you, already?
Yeah, I'm pretty sure we do.
Yeah.
All right. Okay, Kief, thank you very much for your time and all the knowledge shared.